Jai Hind, dear students. Today my lecture topic is software process model. In previous lectures we have already discussed about what is software engineering and what is the requirement of software engineering subject which we are dealing today. So in this series we have also discussed about the various what is the SDLC, that is software development life cycle. In a software development life cycle, we have seen there are the various stages like a requirement. We will begin with the requirement, then designing, then implementation, then testing, and then finally maintenance. So all these phases will be followed in various software process models. So let us understand what is software process and what is software process model. So it is a set of activities, or I will say set of activities or the task or some milestone that is work that will be used for engineer a high quality product, high quality software. We need some kind of activities or some kind of steps for performing or for developing a good quality software. There are the several activities which we will see in a process, and in any kind of software process are that we have already seen in our software development life cycle. First one is specifications. Specification means what the system should do and its development constraint. That means we have to specify what are the requirements of the system, why we need this system. Then we will move to the another activity, that is development. Firstly, we have identified what the system should do, then we have to go for the production of the software system, right? And this development will include the both the things, like if I will say about designing, coding, right? Then after that we will move to the validation. Validation will check the software is doing correctly. That is what the customer need, what the customer required, what the customer wants. Then finally moving to the evolution activity. This evolution activity will be like changing the software in response to the changing demands. It is not fixed. Once we have developed the software, once we have validated the software, that software does not need anything to be changed. So it is a current, according to the current demand, the software has to be, need to be changes. So this process of changing the process is known as the evolution. So these are the following 4 activities which will be done in a software process. These are the some of the software process models. Models means actually on which phenomena we are working, right? On which phenomena we are working. So there are the several models have been defined for a software process development. These software process development models will include the number of models, like first one is your waterfall model, which is a basic classical model for every kind of models. Then iterative enhancement model, then we will go to the rapid application development model, then evolutionary model, after that prototype model, and then we will move to the spiral model. And this spiral model is specifically work on the risk management. Let us start with the basic model, that is the basic classical model, that is the waterfall model. And the waterfall model is the most common and the classical life cycle model. It is one of the, and it is the linear sequential model. So that's why it is also referred as a sequential life cycle model. It is very simple to understand and use. It is very simple. It was like that we can thought of like some waterfall is falling down from top to bottom. So in the from top to bottom we will consider like each phase must be completed in its entirety before the next phase can begin, right? Before the next phase can begin. the least flexible and the most obsolete of the life cycle model, but it is the least flexible and most obsolete. Nowadays, this kind of model is not used, but this model is the base for all other models also. It is a well suited to the projects that have low risk in the areas of user interface and performance requirement, but the high risk in budget, right, and schedule predictability and control. Getting me? That means this kind of model is best suited, suited for the low risk or the small projects, not for the projects, projects which have a use risk in a budget, schedule, predictability. Some of the projects are there which we cannot projects in which we cannot identify the budget and the schedule in the beginning. For those kind of projects, this particular waterfall model is not well suited. Look at this diagram. It will look like a beautiful waterfall way, like we will move from there to there like this. Here the first phase is the input, or I will say when the first phase will be completed, then my next or second phase, that is the design phase, will start. Then our coding phase and unit testing phase will start. Once this has been completed, then my integration and the system testing phase will begin. Then after the system integration and the system testing, then we will move to the maintenance phase. So like this we will move from top to the bottom. All these three phases we all are aware. The requirement and analysis phase and the definition. In this phase we will define the basic requirements, what the user want or what is the need of this particular system. In the system and the software design phase, we will make a design, or we will make a layout or architecture that how our system will look like. Then in the implementation and the unit testing phase, we will code the system, we will go for a physical view, and then we will test them unit wise. Then we will test them according to the components. Then in the integration and the system testing phase, what we will do, we will integrate the various components and test them as a whole, complete system. Previously, in a previous stage, we are testing with small modules or the small components, that we will testing them in a units. Then after that, if one unit is connected to the another unit, we will integrate them and then test. And finally, we will go for the system testing. That means we are testing our whole system. Then last will be the operation and the maintenance phase, where we will provide the complete deployment, and the maintenance phase where the final outcome, like we are doing some kind of process, if there some kind of needs have been changed, some changes will be required, and all these things we will go for either kind of various kind of maintenance we can do here. There are some of the advantages of this waterfall model, that it is a linear model, and it is segmental model. It is a systematic and sequential as well. It is simple one. So it's most simple one. It is the basic model through which one can study how the models can work, and it has a proper documentation. That means every phase has to be documented, like first phase requirement analysis phase has to be documented in the SRS, design phase has to be documented in a particular design documents. After that, we will go for the integration testing, we will provide some test cases, and we will give some last operational and the maintenance, we will provide some operational or the user guides to the user. Here are some of the disadvantages that I have already told you, that this model is not perfect for the projects or the system which are big enough, which are at the high risk, or or for the projects for which the cost and the schedules cannot be identified in the beginning. It is difficult to define all the requirements at the beginning of the projects, right? So it is not suited for those kind of projects where the requirements and all the requirements are not defined at the beginning. model is not suitable for accommodating any kind of change. That means if we have already defined some of the requirements in the beginning, that means what are the things that we have to do, then only I can go for this waterfall model. It does not scale up well for the large projects. Definitely from the beginning I am saying this project is not good for the large project or the high risk projects. It is inflexible partitioning of the project into the distinct stages makes it difficult to respond to the changing customer requirements. Definitely, as we all know ki we need the requirements of the customers are changing. I will say changing on the basis of the need of the requirement, or I will say according to the need, according to the technology, right? So it will not do work well. So this model is only appropriate when the requirements are well understood. So we will use this kind of project, this kind of model for our small projects, for the projects we will be developing for our mini work, or we will be doing for our small scale projects. That means we are developing a project for learning purpose. For that project I can refer to the waterfall model. Or for the some business system that have stable requirements. Some of the systems which have only stable requirements, that every time the requirement will be the same, the requirements will never change. For those kind of system I can refer the waterfall model. Another variation is also there of the waterfall model, that is we called it as a iterative waterfall. In this it has been assumed in a waterfall model that the design that has no error will occur during the design phase. So the iterative model introduces a feedback paths, right? After every stage we will have some feedback path to the previous phase of each process phase. So it is still referred to detect the errors in the same phase they occur. So it will be very easy if some of the error will be there in a requirement phase, that will be easily detected into the same phase, right? If I am having some error, some problem in a design phase, then it will be also predicted into the same phase. So some conduct reviews after the milestone, where we can after some milestone, right? After doing, say if I am saying I have moved from the requirement to the design, right? If I move to the requirement to the design, like this, I am going from requirement to the design. I have identified my milestone, that after the design I will review my complete system. I will review my complete system. That means I am going for the feedback, right? How could I review? I could get the feedback. So I will conduct the reviews after each milestone. So these milestones will be decided by us only, after which milestone I will do the review. Here is the form of the iterative waterfall. Again the same thing: feasibility study, requirement analysis, design, coding, testing and maintenance. But look at here, on after every phase we are having the feedback, right? We are having a feedback line here, here, here and here. So after every phase has been completed, we will get the feedback, whether there is any error or not. If there is any error, we can resolve it at the same stage only. Then another important model that has been evolved after with the waterfall model, that is increment process model, or it will also named as a iterative enhancement model. The word enhancement has been used here. That means we are doing some process, and after that we will introduce our another step that will be the enhancement of the previous one. So in this incremental model, the whole requirement is divided into the various builds, or I will say builds, or I can say them as some components or the modules. Here each build or the module or I will call it as some independent units. These words will be used interchangeably, module or the units. Passes through the requirements, design, implementation and testing. That means each module that we have identified, right, that we have identified, the complete system have been divided into the various modules, and this particular module have to go through the various phases, like requirement bhi hoga there, the design is also there, implementation is also there, and then finally doing the testing. The incremental build model is a method of a software development where the product is designed, implemented and tested incrementally until the product is finished. That means we have to do the work, we have to prepare a build or a model like that ki we are developing a process in a part, and we will repeat this again and again until the product is finished. Let us see here, we can also divide this model like this, that software is broken into the several modules which are incrementally developed and delivered. ठीक है, ऐसे हम incrementally develop कर रहे हैं, that means we are talking about, we are working on a particular module that will be done, that particular module's requirement, they are designing, they are coding, they are testing and finally their deployment has been done. Then we will move to the another module. Whatever the requirements have been changed, they will also be introduced into the another module. So the first, the development team develops the core method of the system, when it is later refined into the increasing levels of the capability of adding new functionalities in the successive version. Firstly, what will happen, the development develops the core modules, right? Whatever the module, like if I am talking about any kind of a ERP system, say we will take an example of university ERP system, when we are developing, so we will develop the core modules, like I am talking about the attendance monitoring, or I will talk about some result management. So these modules have been developed first, and after that we can add some new functionalities in their successive versions, or I will say the successive iterations. Each subsequent release of the module adds the function to the previous release and process continues till the complete system is achieved. So this process will continue till the finally we will got the final version. Look at this diagram. We are working on that, we have identified some particular modules, right? So like I am taking example of say attendance module, or I will say the result processing module, like that. So what we will do, we will produce one increment to the customer. Here the this arrows will show the number of increments, and this will this axis will show you the time. So in the first increment we are doing the same all the steps. Look at these, we are doing the analysis, design, coding and testing, and we will deliver this first increment to the user. Then after some time I will again start our another increment, we will do the same series of steps and we will deliver it to the user. Then the third, then the fourth and fifth, depends upon that how many units or how many increments are to be developed in our particular project. So as the time will begin, here the number of increments will be increasing and your time is also increasing here. Finally at some end we will get our final product, final revised or final version of the product. Here are the some of the advantage of this particular iterative enhancement model. That is very good thing here, that we will get the feedback from early increments to improve our later stages. In the initial stages we can get the some improvement, some kind of improvement has been required in our first initial say I am saying in our first increment, then I can improve it in our second, third or fourth other subsequent stages. The possibility of changes in requirement is reduced because of the shorter time spent between the design of the component and its delivery, right? So the user gets benefit earlier than a conventional approach. Here what we will find, suppose some core module we have designed and we have delivered it to the user. So user can get the benefit of using that particular module, of using that particular part of the system. Smaller sub projects are easier to control and manage. Definitely sub projects part, we can easily manage them, we can easily control them if you will work on a sub projects, or I will say we can work on a various modules. The project can be temporarily abandoned if more urgent work crops up. Like we have seen, there is a major benefit that if we are working on a particular project and it may happen that we have to stop here, right? We have to stop here that our work has been completed here, and it may be possible that we have completed first increment, second increment, then suddenly some other work has been evolved, so we can stop our work here and later on we can again start our third increment after some time, right? So the job satisfaction is increased here for the developer who see their labor bearing the fruit at the regular intervals and the short intervals. Here are some of the disadvantages. Like in this situations, programmers may be more productive working on one large system than on a series of smaller ones. It is a major disadvantage that when we are going to the programmer side, for the developer side, they will not like to work on this kind of work, like the increments where a small task has been done today, some of the task has been done after 1 month, like this. So some problems are difficult to divide into the functional units, so which can be incrementally divided and delivered. There are some of the problems like which cannot be divided into the functional units or the modules, right? So we cannot consider this kind of model for the for those kind of problems which cannot be further subdivided. Software breakage, that is later the increments, may require modification to their earlier increments also. Then now the another model is there, that is RAD model. We have seen the waterfall model, which is a classical model. Then another model is the iterative enhancement model, where we have worked on the various modules. Now the RAD model, it is its name in itself explains that it is a rapid application development model. Rapid, that means some faster. It is this particular model will be proposed when the requirements and the solutions can be modularized. Again, we can now move to the modularized as independent system or the software components, each of which can be developed by a different team. Here we can work like that. We have to modularize our system, right? We have to modularize the system, and we are working on each software component, and each of which can be divided to the different teams. That it is not necessary the same team is working on the all components. Different teams are working on a different component, system components or the system module, so that we can work more faster, we can work more rapidly. User involvement is essential here from the requirement phase to deliver the product. It is the model from where we can work like we need the user involvement. Every time we need the user involvement from the beginning, that is from the requirement phase to the end of the product, to the delivery of the product. So the process is started with rapid prototype and is given to the user for the evolution. User feedback is obtained by the prototype is refined. We will develop a rapid prototype of the system and give it to the user for the evolution. That means whatever the some changes if it is required, then let me know us and we can work on it. Here the user feedback is obtained. Here again the feedback is involved here. Here the feedback is involved here, then the prototype is refined. Here we have seen the we can evolve our system, or we can make our system more efficient by involving the users, by involving their users feedback, and after getting the feedback we can refine our system according to the need of the user. Here SRS and the design documents are prepared with the association of the users. Make sure The SRS is a software requirement specification and design document. These two are the various major documents which has been prepared before the implementation of a system. So, and now it is saying the user involvement is there. So, the SRS and the design document both are to be prepared with the help of your, I can say, with the concern of the users only. RAD becomes faster if the software engineer uses the component technology. This is very important technology which is using currently, that is the CASE tools, that is the computer aided software engineering tools. By using these technologies, your software engineers may work more faster, or it also help in reusing the some components. Suppose we have created some components, I can reuse that component in our another systems, also in our another project, in our another system as well. Since the development is distributed into the component development, the team's work is standard and the total development is completed in shortened time periods. So, this, as I am saying, the time it is a rapid development. So, we can estimate it like that our work has been divided into the various teams, right. The various modules will be given to the different teams. Say M1, I am saying component M1 is given to T1, team 1, M2 is given to T2, M3 is given to T3, and these different 3 modules are developing parallelly. Simultaneously, we are the 3 different teams are working on to the 3 different modules. So, we will come to the very short time period. There are the several 4 phases have been used, which has been proposed by the Martin for using the RAD, that these 4 phases are: the first phase we are knowing the requirement, user design, construction and the cutover. What are all these phases are? Here the requirement planning has to be done, the user description is there, the construction, that means we are talking about the implementation, and the cutover phase. Here we will give it to the user for evaluation and get the feedback, and every time the prototype has to be refined. With the active participation of the users, we can move our project development with all these 4 phases. Planning phase, we all have worked upon it, like the workshop utilizing structured decision of making the problems. Then description phase, where automated tools will be there used to capture the information from the user. Then coming to the construction phase, that means some of the tools such as code generator, screen generator are to be used for making a construction, or for producing, or I will say for making a system. Then coming to the cutover phase, where we will install the system and we will get the user acceptance testing and the user training. This is the cutover last phase, where we will install the system and go for the user acceptance testing and the user training, give the user training. Here are the some of the RAD strengths, or I will say the advantages of RAD, or these are the basic things. That means first strength is that the reduced cycle time and improve productivity with fewer people means lower cost. This is the one of the major cost, like we are having reduced cycle time, right. The cycle time that we have seen in iteration, we have the time span will be increasing, but here we are dividing into the several modules into the several teams. So, with the fewer pupils, we can produce a software with the lower cost if we are using this RAD. Customer involvement throughout the complete cycle minimizes the risk of not achieving the customer satisfaction and the business model. If the user is involved from the beginning, every time he or she, the particular person, is monitoring what is going to be developed, right? What is going to be developed, that particular person will know if the user is involved from the beginning. So, the chances of that the customer will not satisfy with the system at the last is minimized. Focus moves from the documentation to the code, right? Here we will a little bit move to the coding part, that we have moved to the tools also. Then uses modeling concepts to capture the information about the business, data and the processes. Here are the some of the weakness. Every model will have come up with the some strength, weakness, some advantage and the disadvantages. Likewise, your RAD is also having some weaknesses. Here, some accelerated development process must be given to the quick response to the user. Risk of never achieving the closure. Say, thought about if we have involved the user again in each and every step, every time the requirements are changing. Once the requirements are changing and they are keep on changing, then when we should stop our work, when we should stop it, when we should stop that our final version has been evolved. So it may we can move to the we can move slightly towards the risk of never achieving closure. Hard to use with the legacy system, requires a system that can be modularized. That means we can work on only the system that are modularized. We cannot work on the system which cannot be divided into the modules. Developers and customer must be committed to rapid fire activities in an abbreviated time frame. So students, we have seen our other different modules. We have seen the different models. We have listed the models like Waterfall, and then we have seen about the iterative enhancement, then the RAD model. So we have come up with the modules from very smaller to the higher. We will moving to the or more flexible models, right? From Waterfall is least flexible, then we have moved to the iterative, where we are getting the feedbacks and we are creating the increments to the user, right? Giving to the increments to the users, they will be suggesting some suggestion. We will include that in our next increment and then we will deliver it. Then we have involved the move to the RAD model, which is more flexible, which is including the more involvement of the users, more involvement of the client in the development process from the very beginning, from the requirements, right? So we are increasing, so the level of flexibility of developing a project is been increasing from top to bottom. Like we have moved from the Waterfall, iterative, RAD, then we will discuss about the prototype, then we will discuss about evolutionary model, and finally moving to the spiral model. So we will discuss the rest 3 models in my next lecture. Thank you.